In this video, we will learn about how we have to solve equations which involve inverse trigonometric functions. Right? So what do we have? We have a question number 15 of exercise 2.2. Now what it says solve for x when this particular condition is satisfied. Now if we look at this particular question, if it is tan inverse x plus tan inverse y, what will come to my mind? The formula. Over here, I will not be able to verify the condition xy less than 1 before, but once we get the value of x, then we will verify. Right? So what I will do in that case, we will apply the standard formula, that is tan inverse. In place of x, I will write this. In place of y, I will write this. So it will be x minus 1, x minus 2 plus x plus 1, x plus 2 upon 1 minus x minus 1, x plus 1, x minus 2, x plus 2. Right? So now we will quickly solve it up. Let's see what do we get. It is tan inverse. If I take the LCM, it is x minus 1, x plus 2. Then further it will be x plus 1. Then x minus 2. Then here it will be x square minus 4 if I take the LCM, and minus of x square minus 1. So it will be like this. Then further numerator denominator will get cancelled. So I have only written the numerator part after taking the LCM. Now if I solve it further, what will I get? It will be tan inverse. If I solve it overall, I will get x square minus x plus 2x minus 2 plus x square plus x minus 2x minus 2. Right? And in the denominator we will get x square minus 4 minus x square plus 1. So this and this will get cancelled. So what will I get? I will get this as, this will be tan inverse. Let's see. In the numerator we will get 2x square because of these 2x square. This and this will get cancelled. This and this will get cancelled. 2x square minus 4, and in the denominator I will get minus 3. Now this whole thing, I forgot to write over here. This whole thing is equal to pi by 4, which you will be writing in each and every step. So now to solve this for x, what will I do? Since tan inverse is here, what will I do? I will take tan of both the sides. If we take tan of both the sides, what will happen? Inverse will be removed from here, and this will be equal to tan pi by 4. So now I know what is tan pi by 4. Tan pi by 4 is 1. So this will be 2x square minus 4 minus 3 is equal to 1. So now we will solve it as usual. So if I solve it, I will get 2x square minus 4 is equal to minus 3. So 2x square is equal to 1. Right? So then this x square is equal to 1 by 2. X is equal to plus minus 1 upon root 2. Okay? So this is what we will get if we solve this up. Now I have two values of x. One is 1 by root 2 and the other one is minus 1 by root 2. We have to check whether both the answers are the solution or one is the solution. So how we can verify? Just do remember the condition. What was the condition? That we have to check whether this particular xy is less than 1 or it is not less than 1. So let's quickly check this up, whether it is equal to less than 1 or greater than 1. So what do we have? We have x minus 1, x minus 2 into x plus 1 and x plus 2. So this is my x and this is my y. So it is x square minus 1 upon x square minus 4 if I apply the formula. Right? So now in place of x, if I put 1 by root 2, irrespective of plus and minus, I will get the same answer. Let's see what we are getting. So if we put 1 by root 2, it will be 1 by 2 minus 1 and 1 by 2 minus 4. So if I solve this up, what will I get? It will be minus 1 by 2 and this will be 8 minus 1 minus 7 by 2. So what we are getting? We are getting 1 by 7 which is less than 1. It means 1 upon 1 by root 2. It means 1 upon root 2 plus minus is the solution for this. Had this been not true for any one of the value, then we would have said the other value is the solution. But since we have square over here, so the result is true for both. Exam, this is a 4-marker question. Very important. First thing that you have to do is we have to solve for x, and then the verification is of 1 mark. So definitely everybody will be doing the verification, and in the end we will say since it is verified, hence x is equal to plus minus 1 upon root 2 is the solution. Question, this is solved example of NCERT. Again, very important question, 4-marker. Now this can be presented in two ways. One is tan inverse 2x plus tan inverse 3x is equal to 3 pi by 4, or it can be written as n pi plus 3 pi by 4. Both the questions are same. So again, since we have tan inverse term, what we will do? We will apply the formula. So it is tan inverse 2x plus 3x upon 1 minus 2x into 3x is equal to 3 pi by 4. If the other way is, I'll tell you how we will come out of it. So it is tan inverse, this is 5x, 1 minus 6x square, this is 3 pi by 4, right? Now what we will do, again we will take tan of both the sides, so 5x upon 1 minus 6x square is equal to tan 3 pi by 4. Then tan 3 pi by 4, what do I know? Tan 3 pi by 4 means we are in the second quadrant. It can be written as, I'll write it here, pi minus pi by 4. So tan pi minus pi by 4 means what? Minus tan pi by 4, which is minus 1. Similarly, had it been tan n pi plus 3 pi by 4, this would have been 3 pi by 4 only, because n pi means where n is integer. So n pi means 1 pi, 2 pi, pi plus something. So we will write it in the third quadrant, so it will be written as 3 pi by 4, right? Then further, this is 1, so what we will do, we will write it as 5x, 1 minus 6x square is equal to minus 1. Then further if I solve, this will give me 5x is equal to minus 1 plus 6x square if I cross multiply. So this will be 6x square minus 5x minus 1 is equal to 0. So since I have a quadratic equation, to solve this up, we will, it is a quadratic equation, we will split it as minus 6x plus x. So if I take 6x common, it will be x minus 1. Over here we will write x minus 1. Then again we will write the factors. So it will be 6x plus 1. Then x minus 1 is equal to 0. So my answer for x will be equal to minus 1 by 6 or 1. Right? Now we have two solutions. So again we have to check the condition. What is the condition that we have to check? X, y. X is 2x and y is 3x. So this is my x and this is my y. So I have to multiply and see whether the result is coming out to be less than 1, because we have applied that formula. So what is it? It is 6x square. So now if I put x as minus 1 by 6, it will be 6 into 1 upon 36, which is 1 upon 6, which is less than 1. If I put x as 1, it will be 6x square, which will be equal to 6. So which is greater than 1. It means this condition is satisfied only for x is equal to minus 1 by 6. So x is equal to minus 1 by 6 is solution. Right? So this is how you have to verify. This is question number 13 of miscellaneous exercise. Now what we have, again we have to solve for x. Now what do we observe? We have 2 tan inverse a particular angle on one side and tan inverse on the other side. To compare, what we need is we have to change this also to tan inverse. So there is one formula which changes to tan inverse, that is tan inverse 2x upon 1 minus x square. So then this will be 2 upon sine x, right? So now what we will do, I can compare tan inverse and tan inverse on both the sides. So it will change to 2 cos x upon sine square x is equal to 2 upon sine x. Now over here, since this is defined for tan inverse over there, so x is not equal to 0 because tan inverse ranges from minus pi by 2 to pi by 2. So I can cancel this sin x with 1. So I'll have cot x, because one sign will be left, cos upon sin is cot, and this is 2 and 2 can get cancelled. So cot x is equal to 1. Now what we have to think? We have to think when is cot x equal to 1. Since it is inverse function, we don't have to go into the general solutions. We only have to think of the particular solution because of the restricted ranges. So x is equal to pi by 4 will be the solution. So if I put this pi by 4 in the given equation, are both the sides equal? Let's verify. So over here, 2 tan inverse cos pi by 4 will be 1 by root 2. And over here, tan inverse 2 into cosec will be root 2. So if I put up the formula, both the sides will come out to be equal. Hence, x is equal to pi by 4. For this particular question as such, we don't have to verify because over here, we are not applying the formula of tan inverse x plus tan inverse y. So that is why we can simply say x is equal to pi by 4. This is a 2-marker question, right? So next we have a question, that is question number 14, which is tan inverse 1 minus x upon 1 plus x is equal to 1 by 2 of tan inverse x. Again, what we have to do, we have question number 14. So what we have in question number 14 is, if I see the right hand side, I can write it as tan inverse 1 minus tan inverse x is equal to half of tan inverse x. If you observe this question carefully, if I apply the formula reverse, just see tan inverse A minus tan inverse B, tan inverse A minus B upon 1 plus AB, right? So this can be in place of tan pi inverse 1, we can write as pi by 4, and this half tan inverse x plus tan inverse x will be written as 3 by 2 tan inverse x is equal to pi by 4, right? Then further what we can do, if I solve this up, what will happen? This 2 will go to this side, I can cancel it over there, and this is this. So pi by 6 is equal to tan inverse x. Now if I take tan of both the sides, what will happen? This will be tan pi by 6 is equal to x. So what is the value of tan pi by 6? Yes, you are right. It is 1 by root 3. So x is equal to 1 by root 3 is the solution. Question 15. So what we have now, sine of tan inverse. This is a 1-marker question, very easy. As you can see, we have done it before also. So tan inverse I need to change to sine. So how can I do it? So it can be written as sine. This further if I do by Pythagoras theorem. So this is perpendicular upon base. So this will be 1 plus x square. So if I change it to terms of sine, so this can be written as sine of sine inverse x upon under root 1 plus x square, right? So sine and sine inverse will get cancelled and my answer will be x upon under root 1 plus x square. So this can be a MCQ question. Next what we have, this question number 16, although it is MCQ question of miscellaneous exercise, but this is asked as 4-marker, very important question. So what we have, sine inverse 1 minus x, and this is 2 sine inverse x is equal to pi by 2. Again we have to solve for x. So now what we will do is, we will keep this thing over here. I'll just write it like minus 2 sine this, and this can be written as pi by 2 minus sine inverse 1 minus x, right? So now what do we know? Pi by 2 minus sine inverse x is cos inverse x. So this will be as it is. This I'll write as cos inverse 1 minus x. Then further what we will do, I can write this cos to this particular side. So this will be cos, taking cos of both the side, minus 2 sine inverse x is equal to 1 minus x. Right? Now what we have to do, we have to substitute x something so that inverse get cancelled. And over here if sine inverse x is present, I can put x as sine theta. Right? Now let's move further. So what is it? Cos of minus 2 theta is equal to 1 minus sine theta. Cos minus theta is cos theta only, so no problem. 1 minus sine theta will be here. Now to solve this, I have to apply the formula of cos to theta in terms of sine. So this can be written as 1 minus 2 sine square theta, 1 minus sine theta. So 1 and 1 will get cancelled, minus and minus will get cancelled. I'll not cancel sine with sine because we have to find out the solution. So what I'll do is I'll take common. So it will be 2 sine square theta minus sine theta is equal to 0. So I can take sine theta common. So it will be 2 sine theta minus 1 is equal to 0. Over here, if I compare, I'll get sine theta is equal to 0 and sine theta is equal to 1 by 2. So what was my sine theta? X. I don't have to solve for theta. X was my sine theta. We have to solve for x. So x is 0 or x is 1 by 2. Now what? Again we have to verify whether x is equal to 0 and 1 by 2 both are the solution, or simply one of the value is the solution. So what I will do, I will just put both the values in the given equation. So if I put 0 over here, so what will this change to? This will be sine inverse 1. This sine inverse 0 will be 0. So sine inverse 1 and which is pi by 2. So both the sides are equal. So it means 0 has satisfied. Now if I put half, so this will give me for half, it will be sine inverse half minus 2 sine inverse half. Which means this will be sine inverse half means this will be pi by 6 and this will be 2 into pi by 3, which will not give me answer as pi by 2. Hence x is equal to 0 is the only solution because x is equal to half does not satisfy the equation. So